Hello everyone, welcome to today's stream. I hope you are all excited to dive into Leetcode Biweekly Contest 138's review as well as discussion of how it could be solved and how the codes can be made better. Hope you are gonna enjoy the stream. So guys, we'll go to the first question of today. The first question. Okay, first, let's see. Did any of you attend the contests amongst the viewers? Okay, let's go to the first question. The first question, maximum difference between adjacent elements in a circular array. Given a circular array nums, find the maximum absolute difference between adjacent elements. Note, in a circular array, first and the last elements are adjacent. So, they have given an example. Nums, array elements of the array are 1, 2, 4. Output should be 3 because the difference between 1 and 4. Going on next, -5, -10 and -5. So it will be absolute difference -5 minus of -10, which will be equal to 5. So the constraints given are 2 smaller than or equal to nums dot length, and this will be lesser than 100 or equal to 100. As well as the indexing, like the maximum number of elements will be like 100. Here it's given nums of I will highest be 100. So for this, we are gonna use a function. First of all, we'll create a class solution. Then we'll create a function called max adjacent distance. And this function will have two elements, two, what do you call, two variables. First one, self, and the second one is a list of integers array. So here, okay, we'll go on to the first question. For this question, we'll go for the inclusion first. In a circular array, like in a circular array, the first element and the previous element, the last element will be actually they will be the adjacent elements, and the last element is always adjacent. So we have to find the maximum difference, maximum absolute. So 1 and 2 as well as 1 and the last one, like element in the indexing of 0 and the element in the indexing of 1, or the element in the indexing of 0 as well as the element in the indexing of n. In this, we have to find the highest. So going on, we can use this approach. First, we'll initialize, for example, like calculating the absolute difference so that we can get the maximum difference here. Like we can store it in mx. We'll make a variable maximum like mx. And then we'll just make a loop and iterate through the array using the max function basically. Update it, like we have to update the max now with the maximum difference. For that, what we'll do is we'll update mx after we compare it with the absolute difference between each pairs. So next, we have to return the result. This is a very simple question of arrays or circular arrays. The time complexity of this question, anyone in the chat, it's a very easy question. So the time complexity for this, it's gonna be O of n, because the length of the array will be n, like the length of the array nums will be n, and every, like it has to run through, the loop has to run through every element. So it's gonna be O of n. Now we'll go to the code. Listent max mx. This mx is to store adjacent sum. I think there's no need to write this. This loop to calculate absolute max difference. And here, there's the only like major thing here. The thing here is the main thing where we have to focus here is it's not just an array, it's a circular array. So the first element is also like adjacent to the last element. So we have to focus which is having the highest sum, like the maximum sum. We'll give this, we'll submit this question. Okay, so here we are. And the time complexity of this is O of n, and the memory complexity or the space complexity will be O of 1. Since like only for mx, there's only one space used for this mx here. Uh, Anyone has any doubts in this question? Guys, anyone, any doubts? Guys, anyone has any doubts? So okay, we'll move to the second question then. Like, if all are clear with the doubts. Yep. Okay, the second question. We'll close this. So the second question is minimum cost to make arrays identical. If you are given with two integer arrays, ARR and BRR of length n and an integer k. So there are two arrays given. One is of length n and there is an integer k. You can perform the operations on array any number of times. It's mentioned here operations can be performed any number of times. Split array into any number of contiguous subarrays and rearrange the subarrays in any order. This operation has a fixed cost k. Cost of splitting will always be k. Choose any element in ARR and add or subtract a positive integer x to it. The cost of this operation is x. return the minimum cost, total cost to make ARR equal to BRR. So for example, a subarray is a contiguous non-empty sequence of elements within an array. So they have also given the definition of a subarray here. So we'll just look into the example here. Input ARR is equal to the ARR. The first array is equal, the elements of that array are -7, 9, and 5. And BRR, the elements in BRR are 7, -2, and -5. And the value of K is given as 5. So I have given the output as 13. So why 13? We'll go into the explanation here. Split the first array, the ARR, into two contiguous subarrays, which one is -7, the other one is 9 and 5. We have to now again rearrange them into 9, 5, -7, and this will cost us 2. Like the cost of this is 2. And now if we subtract 2 from every element, this array is gonna become 7, 5, -7. And the cost of this is also 2. And now if we subtract 7 from element ARR of 1, array in the indexing of it is 1. So the 5 is the number here. So if we subtract 5 minus 7, it is -2. So -2 is here, and this -7 will be -7. The cost of this will be 7 because we are subtracting 7. Add 2 to the element ARR2, the array becomes 7, -2, -5. So which is equal to BRR. So this array is equal to BRR, and the cost for this will be 2. Now, this first 2, cost of splitting it and rearranging it, then the first operation ARR of 0 index position, and the second operation ARR of 1 position, and finally the third one ARR of 2. So 2 plus 2, 4, 4 plus 7, 11, 11 plus 2 is 13. The total cost of making arrays is 13, so the output is gonna be 13. I guess the question is clear. So for this, we are gonna use like for example, the intuition is gonna be like the goal is to make two integer arrays equal, ARR and BRR. Okay, so going on, the cost is proportional to k. If the number of like the value of k is high, then obviously output value is gonna be high. Now will you go for the approach directly? Which approach we can use actually? Okay, first one, direct adjustment cost calculation. Here, first we'll compute the cost of making ARR equal to BRR without any rearrangement. So, basically, what the step says is we'll ignore the step. We'll ignore the step first, and then what we'll do is this is gonna represent a scenario where if we do not rearrange subarrays, but we'll just modify each element of ARR to match it to BRR directly. For example, instead of rearranging and all this here, we'll directly like -7, we are gonna change this -7 to 7 directly. That's what we are saying it here now. Now, rearrangement and adjustment cost calculation. So, both the arrays and like ARR and BRR. We'll take it as 1 and 2, it's easy. The ARR, like ARR I'll just write it here so that you guys won't get confused. As ARR equal to 1, BRR equal to 1. Not equal to, is named as 2. Just for saying, just for explaining. Okay, so that you guys won't get confused while I'm explaining this. So yeah, array 1, we'll name it as 1, and like arrays ARR is named as 1 and BRR is named as 2 for explanation. Now we have to sort both ARR and BRR. Basically, we have to sort both 1 and 2 arrays and calculate the cost of making the sorted array equal to sorted array 2, which is BRR basically. After sorting, we'll take the differences between corresponding elements because it might be smaller so that it can reduce the adjustment cost. Like it will obviously when it's sorted, every element will almost be similar and the differences will be closer compared to unsorted array. Now we'll go for next. What we'll do is the sorting process here is done basically like mainly to minimize the differences between elements. So for example, if we take Hmm. Okay, we'll take this as 2, 1, 3, and next we'll take 2, 1, and 1, 2, 3. Now, if we sort the first one and second one, like 1, 2, 3, and 1, 2, 3, now the difference is very less. So the least difference, to just get that minimum difference, we are gonna sort it. Now, what are the constraints for this? Array's length is less than 10 power 5, case length is less than 2 into 10 power 10, array of I is between like less than 10 power 5 and greater than 10 minus 10 power 5. Same for B array of I. Now, the final step, optimal cost decision. Like to find the final cost, what we are gonna do is we have to return the minimum of two computed costs. The first one is we are doing it directly, and the second one is we are doing it with adjustment and rearrangements. So what will happen here? We'll simply directly call this min function. You all are aware of this min function, min max functions in Python. So what we are gonna do is we are basically gonna call this min function here to determine the minimum. So yeah, going on to the code now. I'll just remove this. Like I guess all are clear. If I use array 1 and 2, you guys won't be confused. I guess now. Now, first what we are gonna do is we'll just declare all this the class solution like and they are already given the cost like function name and all. Define the function min cost and self comma a list of integers and an integer k. And here what we are gonna do is first we'll add a conditional statement like for example this conditional statement. Why? If arrays are already equal, if 1 equal to 2, array 1 equal to 2. If arr 1 equal to arr 2, then there is no need of all these things. We can directly return it. So yeah, then there will be like the number of steps required will be actually 0. So we have to directly return it. Now, n is equal to length of a. N is length of array, both the arrays. Now going on to the next one, answer 1 is equal to sum of absolute difference between A of I minus B of I. So what is this? This is basically the first step. We are directly getting the sum, like the difference. We are directly getting sum between both the values. So basically here we have used minus. So technically we are using sum function and this absolute function ABS to get the absolute value. So we'll just write it here, direct method. Now, A dot sort, B dot sort, simple like array dot sort, which is again a function, inbuilt function in Python. Okay, so we are using A dot sort and B dot sort. So you might be aware of this sorting technique called tim sort. Here, tim sort will be used when we automatically give it to sort, like array dot sort. Again, this will run with the best time, like the stim sort. It is gonna run with the best time complexity called O of n, and the worst time complexity as well as average time complexity will be O of n log n. And the space time complexity, sorry, the space complexity will obviously be O of n. Now, going back to the question, this is just sorting both. I'll just write sort, Yara, sort, Biara. So yeah, now this is after sort. After sort cost. This is direct method cost. This is after sort. Now this is the final answer we need. The final. What is this? This is the minimum cost. Minimum cost of making like minimum cost of making the arrays identical. This is the minimum cost. So we'll try running this code and it works perfectly. We'll submit it. Okay. So here you are. It's accepted. Now we'll directly go to the fourth question. We'll come to the third question later. The fourth question. Manhattan distances of all arrangements of pieces. Okay. Seems a nice name. It's the name of a place. Going on, like, what is the question? We'll go through the question. You are given with three integers, okay? M, N, and K. So there's a rectangular grid. Oh, nice. There's a rectangular grid of size M cross N containing K identical pieces. Return the sum of Manhattan distances between every pair of pieces over all valid arrangements of pieces. Valid arrangement is a placement. They have given the definition of valid arrangement here. Valid arrangement is placement of all k pieces on a grid at most one piece per cell. It is similar to how we solve like Sorako kind of thing. Like we'll just put one element in one cell. Since answer may be very large, return it. Sorry. Since answer may be very large, return it modulo 10 power 9 plus 7. The Manhattan distance between two cells, they have given the formula for it. Xi, yi and xj, yj is x minus xi minus xj plus yi minus yj. This is simple distance formula, similar to distance formula. So we'll check the example. Input m is equal to 2, n is equal to 2, and k is equal to 2. So what is the output? How many arrangements can be made? Valid arrangements. We'll see it. PP. We'll just put P as the pieces here. So PP, PP, and PP, and like in 1 comma 2, right one, left one, up one, down one in the opposite sides, and now in the both the down and now two diagonals. So now what we'll do is we have to get the sum, right? The total sum. Okay. So yeah, we have to return the sum of all the distances. It can go very high value when the value of input is high. Now we'll go for this first four arrangements. In all these four arrangements, the distance between two pieces is just one. Like it is if we take 1 comma 1, 1 comma 2. Here it's 1 comma 1 and here it's 2 comma 1. And here it's 1 comma 2 and here it's 2 comma 2. 2 comma 1 and 2 comma 2. But here it's like 1 comma 1 and 2 comma 2. And here it's 1 comma 2 and 2 comma 1. So in the last two arrangements, the Manhattan distance is 2. Between the two pieces, it is 2. So the total distance now is gonna be 1 plus 1 plus 1 plus 1 plus 2 plus 2, which is gonna be equal to 8. So this is 1, 1, this is 1, this is 1, this is 1, this is 1, and it's 4 total, and this is 2, 6, and this is 2, 8. So yeah, the output is gonna be 8. And this is a very simple question actually. Leetcode marked it hard. I don't know why. It's a very tricky but very simple question. For this, we are gonna use this way. The intuition is basically, yeah, we have to calculate the sum of Manhattan distances, which is the distances basically in an M cross N grid of all the valid arrangements only. For example, if two are placed in the same, like for example, here we'll just go here. Instead of this p comma like p in one like in this 1 comma 1 and 2 comma 2, if both the p's are in 1 comma 1 itself, then it's an invalid arrangement. So we are not gonna consider that. Now we'll go for the approach. The approach we are gonna use here is combination calculation. First thing, the code uses combinations to select how many, like to determine how many ways it can select k minus 2 remaining pieces after placing two pieces on the grid. Like it will place two on the grid first, then it will check how many it can, how many ways it can. Then it will do a function, combinatorial function, which is combination like COMB of n into m minus 2 comma k minus 2. I'm sorry. So here, if you calculate the number of ways, it's basically the combinations, the number of combinations or the number of ways. This is the combination function, which is an inbuilt function in Python, which we have used. So yeah, we'll use that function. And what we are gonna do, we'll calculate the number of ways for calculating Manhattan distance. It can be 10, 20, 30, depending upon the grid as well as the input. Manhattan distance calculation. Now we have found the number of ways. Now we have to find the Manhattan distance. Basically the distance between the elements. All the distance we have to find. Now we'll break it into two things. First, this is a grid basically. So grid has rows as well as columns. So we'll just break it into rows and columns and we'll take it as two ways. One, taking the distances along the rows and taking the distances along the columns. Now, for rows, we'll run a loop. In this loop, what we are going to do is we'll run a loop up to the range of n minus r minus 1. And for columns, exactly the same group where m minus c minus 1. It will calculate the contribution of all these distances across rows and columns respectively. Now what we have to do, the last part, we have to sum all of them. Like we have to just add all of them. So for this, we have to add rows and columns. We have to sum both of them to get the maximum like the total Manhattan distance for all valid arrangements. It's not maximum, it's the total Manhattan distance. And finally, uh, as they had said that the result can be large, we have to simply return result modulo 10 power 9 plus 7 to avoid overflow and to give it for the given constraints. What are the constraints? We'll just see it again. 10 power 5, 10 power 5. Okay, m into n will be lesser than 10 power 5. K is lesser than m cross n, like m into n, and m and n are lesser than 10 power 5, and both are like higher than 1 and higher than 2, respectively. So we'll go for this. So yeah, okay. First thing what we are gonna do is we'll import math and all. Like we don't need to import it actually because Leetcode actually gives us all the facilities. If we want, we can actually import it. I'll import, like if you want, you can add this import math and import com for combinations. You can use this too. If you are running this code in an external environment, remember to add both of these points because without that you will get an error for using this combination function, as well as wherever we'll be using min, max, all those stuff, we'll have to import this math library. So here we have imported both the math library and the combinations. We'll go ahead. Then the class solution, which is given, and the function name distance sum, which is also given. Now what we'll do is we'll take a variable ans and we'll declare it to 0. And this is gonna give us like the k minus 2 pieces, like the combination, number of combinations. Like it's gonna give us the number of combination. We'll keep it COMB. And now contribution is equal to. So now this contribution is gonna give us, okay, this contribution is gonna give us the total number of combinations. Total number of combinations. Now, the first few, as I said, for R in range, anyone in the comment section Can you say what it is? For our, the first loop is used for, so the first loop is used for rows, sorry, rows, and the second one for columns. The contributions across columns and the contributions across rows for C in range and for R in range, n minus 1 and m minus 1. Thus, I already explained. Now we'll go for the final calculation. The sum. This answer is the answer plus or equal to, we have used shorthand instead of answer is equal to and then answer plus plus. Instead of that, we have directly used answer plus equal to contribution into n into m, sorry, n into m minus c minus 1 into m minus c by 2. So now what we have to do is we have to finally return this thing. The answer as modulo of 10 raised to 9 plus 7. Now we'll run this code. We'll check if it is correct. Yeah, it's for the test cases it's given. Now we'll submit this. Okay, so it's accepted. Anyone in the chat, can you guys say what might be its time complexity? So guys, the time complexity. Two different for loops. Very basic question. Very basic thing. Two different for loops. One is for rows and the other one is for columns. And one has n elements and the other one has m elements. O of n plus O of m, which is equal to O of m plus n. So yeah, the total time complexity of this is gonna be O of m plus n. So yeah, this is gonna be the total time complexity. Now we'll go to the third question, and for us it's the last question actually. This is actually a very interesting question. And it is my favorite question from today's contest actually. We'll go to the question. Longest special path. Okay. The longest special path, you are given with an undirected tree. Undirected tree, there's no directions given. Rooted at node 0 with n nodes numbered from 0 to n minus 1. Represented by a 2D array, edges of length n minus 1, where edges I is equal to u of I, comma v of I, comma length of I, indicates an edge between nodes ui and vi with length I. For example, if edges of 2 and it's between like edges of will take I is equal to 2 here and it will be 2 comma 2 and the length will be given between them. We'll take u is equal to 3 and v is equal to 4. So it will be the length will be 1. So it will be like edges of 2 is equal to edges square brackets 2 bracket close is equal to 3 comma 4 comma 1. This is just an example I gave. Now you are also given with another integer array named nums, where nums of I represent the value at node I. Now here comes the major thing. The special path is defined as a downward path from an ancestor node to a descendant node such that all the values of the nodes in the path are unique. Note that a path may start and end at the same node. Return an array of size 2 where result of 0 is the length of the longest special path and result of 1 is the minimum number of nodes in all possible longest special paths. Again, return the result of size 2, where result of 0 is the length of longest special path and result of 1 is minimum number of nodes in all the longest special paths. So like we have to return array basically. For example, okay, anyone has any idea like how we can do this question? I'll just shift it so that we'll get the question. Anyone in the chat, guys, any idea how this can be done? Okay, Mayan Patni. Okay, I'm just going through the comments for a second. By then, anyone can figure this out. I have done BCom, want to enter in it industry. So how to enter in it? Should I gain tech skills or should I do MCA or MTech in computer science? Or is it possible to enter in it without a tech degree? So basically for competitive programming or what we call like contests and all, there's no need of a degree. Anyone can do it. All you need to have is a Leetcode account for this contest actually. But if you need to enter the tech path completely, then it depends upon where you wanna work. Some companies might accept you with good tech skills, even with your BCom degree. But it's better if you have an MCA. And with BCom, there's no chance that you're gonna get an MTech degree in computer science. So yeah, you can get into computer science. Anyone can do it. It's all your interest and the hard work you put in. So Mayan Patni, I guess I have answered your query. Okay, any more doubts, any of you guys? You can ask me. No. Okay, I'm going to solve this question now. What is the intuition for this? Intuition. It requires finding the longest path actually of a tree. And special path is downward path from ancestor to descendant of a tree. Our goal is to maximize the path length and also the we have to minimize the number of nodes. We have to maximize the path length, but we have to minimize the number of nodes. So that's why I said this is a very interesting question. How? Approach. First thing, okay, at least can any of you guys in the chat say which is the algorithm that's gonna be used? Guys, any of you, which is the algorithm which we can use for this? Okay, we have a comment. Yeah, it is correct. It is DFS. We are gonna use depth first search here. So before that, what we have to do? The first step will be graph representation. We have to convert the input, like the list edges into adjacency list, so that we can represent it as a tree. Now, distance calculation. First step, distance calculation. We have to use DFS and then to calculate the distance from the like to calculate the distance from root node to all the other nodes. Now here is the twist. It's not just DFS. With DFS, we have to use backtracking. We have to come back, like we have to also integrate backtracking along with depth first search so that we can explore all the paths in the tree during the traversal. So, what are the steps during the traversal? Very important. We have to maintain a path stack to keep track of current path and the last occurring array to sort the last occurrence of each node value. And next, we have to use minimum index to track the lowest index in path stack where values are still unique. Next, calculate the path length as the difference in distances between the current node and the ancestor at minimum index. And then we have to update the maximum path length, which is max length, and minimum number of paths, like minimum number of nodes for this maximum length. Here we have to, this is our main answer. This is what we have to update. Maximum path length, which is max length, and minimum number of nodes, which is min nodes for max length. Now, the next step, the fourth step is backtracking. Once we explore all the descendants here, right, we have to backtrack by removing the node from path stack, and also we have to restore it back to last occur and minimum index to the previous values. We have to restore last occur and minimum index to their previous values. Now, how we are gonna do this here? Okay, now this is basically array list, adjacency list. Okay, adjacency list. Int all this declaration, int is number of nodes. You're well aware. Nodes, nums, values, value at node, and distance, distance from root. Okay, last occur, it's the last occurrence in DFS. Oh shit, sorry. DFS last occurrence. Okay, and next array list, again an array list to, okay, there's a stack actually we are creating here, path stack. Why are we making this? This track is to track the current path during DFS. Current path during DFS. Now, min index, max length. Min index, minimum index required. Minimum index for, sorry, minimum index where values are unique. Okay, now max length, obviously, maximum length, the final answer. This is our final answer. Max length of special path. So yeah, now we'll go for this thing. This is all the basic stuff. Like this is all given. The class solution is given. This is given. Public integer longest special path, and its attribute, like everything is given. Now we'll use this keyword here. This dot n nums length. This dot nums equal to nums. Now here will come. Okay, this build dist. What is this? Build dist 0 comma minus 1 comma 0. This is distance from root to all other nodes. This is to calculate this. So I'll just add calculate. Calculate distance from route to all other nodes. Now, going ahead and next, what else? This basically will next run a loop for value which is greater than max value. This just to determine the max value. Very simple comparison we are doing. Where if the value is greater than max value, then max value will be equal to the value. So yeah, we'll go ahead next. Okay, this is where we are gonna start DFS from root node. Start DFS from root node. Okay, and next here we are gonna return our integer max length. This is a major thing, which is our final answer actually basically. Max length and minimum nodes for max length. But still there's a lot left here. Next we have to calculate distance from distance of each node from root node. For that we are making this public void DFS. Okay, sorry. For this we are creating this method public void build dist. What is this gonna do? Calculate distance of each node from root node. Okay. Now, here what we are doing for integer edge and u we have given adjacent selects u. Integer v is equal to edge of 0. W is equal to edge of 1. If v is equal to parent, continue. Build distance, we are calling this build distance where we had used this function, like we had used this method earlier in the code. Now we'll go for the next one, next method. Here we are gonna call public void DFS. Here, this is used for DFS to explore paths and find longest special path. Longest special path. This is our main, like, there's our main answer, like longest special path. That's the title also, the longest special path. Now we'll come to the, this is basically like, here's where the backtracking comes, removing of this one. This is the backtracking here. Oh shit, sorry. Here we are doing the backtracking, and this last occur, we are gonna restore the last occurrence, and thus we have to restore the min index. So I guess you guys are clear with it. I have added the command so that you can easily read this. This is path length. If the path, again, similar to what we did, value in value. Here, this if condition. If path length is greater than max length, then the max length should be the path length. So max length is equal to path length. And minimum nodes is equal to path nodes. Else if path length equal to max length and path nodes smaller than minimum nodes for max length, minimum nodes for max length is equal to path nodes. Here basically we are getting the least number of path nodes, like the minimum number of nodes required for the maximum length. For example, if max length is equal to 10, we'll have two ways for it. And first way it will be the path nodes will be 3, and in the second one the path nodes will be 4, for example. Then we'll go for this else if condition where if when both are equal, path length and max length, we'll have this condition, and path nodes which one of the path nodes is smaller than minimum nodes for max length, Then minimum nodes for max length. The minimum nodes required for maximum length will be equal to the path node. For example, it was earlier 4 in the example I gave, now it's gonna be 3. So minimum nodes for max length is gonna be 3. And next, what else is there in this? Yeah, that's all. This is just like we are just adding like stack. They are doing stack operations here. Now, I guess we are all clear with this. We'll just run this code. Okay, wait. It's accepted. Now we'll submit it. Okay, we are gonna submit this one. So yeah, here it is. The code is perfectly running for all the test cases without any time limit exceeded or any other errors. Hello Puneet, welcome to the stream. Yeah. So guys, if you have any other doubts regarding today's, okay, sorry to say, I just forgot to say the time complexity of this. Anyone in the chat, what is the time complexity of this? Okay guys, anyone in the chat, what is the time complexity of this one? So the time complexity of this for building the graph, it's gonna be O of n because n is the number of nodes and each edge should be processed once. So it's gonna be O of n. And now DFS traversal. Again, DFS traversal also uses O of n because every node and every edge is visited exactly once. So the total time complexity of this is gonna be, again, anyone in the chat, what is the total time complexity of this? It's gonna be the total time complexity. Anyone in the chat, guys? Yeah, it's gonna be O of n. So yeah, that's all for today's stream, I would say. I guess I didn't forget anything. Or did I forget anything? No. Okay, I forgot to say the time complexity of this one. Which one? The second question, minimum cost of making arrays identical. It is again like arrays question, single for loop. It's self-explanatory. If it's a single for loop used for a single time, we can directly put it as O of n. And the space complexity used will be O of 1 here. And for the fourth question, which is Manhattan distance. Manhattan distance. Anyone, what is the time complexity of this? O of m plus n. I guess I told this. Yeah. So guys, that's all for today's stream. All the 4 questions were solved. Anyone, what do you guys think? How was today's contest? If anyone gave the contest. I personally felt that the third question was a bit very lengthy. If anyone like Java users especially, it was very hectic for Java users, I guess. And the fourth question, as always, from past 2 weeks, I don't know, it's Leetcode trend, I guess. They're giving a very small piece of code for the last question, but they're giving it very tricky. Maybe yeah, like that's the reason why there are nowadays a lot of people that who are giving 4 out of 4. Oh, nice. Rohan Gaming Tech. Nice, bro. Congratulations. What was your rank today then? You solved 4 on 4. That's great. What was your rank today, bro? That's really good, Rohan Tech Gamer. Rohan Gaming Tech, sorry. Keep it up. Keep doing it. Anyone else? Oh, nice. Rank 337. Congratulations. Anyone, any doubts, guys, regarding any of today's four questions or any other Leetcode question, like any other question? I'm gonna solve it on the screen now. If you have any doubts. Rohan Gaming Tech, you can please give your Leetcode ID so that the people in like other people watching the stream or anyone else can actually watch it. Puneet Gowda, I will follow your live next year. Thanks, brother. Okay, guys, we'll end the stream for today. Thank you everyone for joining the stream. Bye, guys. Have a nice day. Good night. Bye bye. Thanks for joining.